Hello and welcome to the unit on learning, basic operations, and timing. And so the reason we've covered behavior and environment, and so we really have focus on just defining behavior and defining environment and contrasting the two. So now we're going to begin to focus in the next several units in this course on functional relations between behavior and environment. And so to begin talking about functional relations between behavior and environment, we'll begin by defining learning in relation to behavior change in an organism's experience through interacting with the environment. And then we'll talk about those basic operations and aspects of timing that influence, that is, predict and control learning. And by basic operations, what I'm referring to are antecedent and consequent manipulations that occur in the environment. And by timing, I mean the temporal relation between stimuli and one stimulus and another stimulus, or between responses, or between stimuli and responses. So it's the time between stimuli, the time between responses, or stimulus-response events. So let's get started. We'll begin here with objectives 1 through 6. Objective 1 is just to define learning. Objective 2 will be for you to list 2 general ways people learn and discriminate between examples and non-examples, and then to define data and discriminate between examples and non-examples of each. State the fundamental datum in behavior analysis and its relation to response strength and probability. Define contingency. List types of contingencies and state the strongest kind of contingency, and then to identify types of contingencies in scenarios, meaning we're going to apply that information. So our first objective is to define learning. And there are a lot of different ways we could define learning, and we're going to apply what's called a pragmatic definition of learning, or a definition of learning that is useful for studying functional relations between behavior and environment. And learning is difficult to define, and definitions are controversial, but really different definitions of learning are just applied to different levels of analysis. So studying the physiological basis of behavior might utilize a definition of learning that's different from analyzing behavior at the level of the environment, so behavioral level of analysis. Folks who are interested in the relationship between learning and culture may define learning differently. A neuroscientist studying learning maybe would define it differently, and so forth. And there are, so we'll begin here with this definition. So for our purposes, we'll define learning as a relatively permanent change in behavior resulting from experience. Okay, so it's a lasting change in behavior. It's a change in behavior that is observed over time through repeated observation and is detected through repeated measurement. And it results from experience. And by experience, we mean those interactions between the behavior and the environment. Now, as only individuals behave, learning cannot be represented by group averages. Okay, so learning is a process, okay, that occurs within a single living organism. So that's our focus. Learning as a process. It's a relatively permanent change in behavior resulting from experience at the level of the individual organism. And learning through experience then can be affected by changes in antecedents and consequences. That's what experience is here, those changes in antecedents and consequences, through many different environmental operations as indicated by graph data. And so there are many ways that we can describe learning through measurement. in the process of collecting data that you can graph to observe learning occurring and to predict and control changes in behavior, or predict and control learning. And so examples of measurement would include direct measurement, so measuring the duration, dimensional quantities of behavior such as duration or latency or rate. And then you can also describe learning through indirect measurement, such as calculating the percentage of opportunities or percentage of trials an individual exhibited the correct response. You can also measure variations in topography and so forth. So a lot of different ways you can describe learning through measurement during as a result of observation. And there are two general ways that people learn. And your job is to list two general ways that people learn and then to discriminate between examples and non-examples. So the first way is learning with words. And examples of learning with words include the following. So let's say you suggest a child pretends the banana is on the phone, is a cell phone. And then they start talking to the banana like it's a cell phone. Okay, so that behavior was preceded by you suggesting that they do that. So that would be an example of learning with words. Or there's a classroom rule stated. Line up behind a friend before we leave the room, and the student gets in line accordingly. Or you tell the student when to use periods and commas in sentences, and then they begin to do so. Or the student didn't know where the lunchroom was, but the hall monitor explained it to them, and they were able to find it. You can also learn without words, and some examples are after, let's say, a son and his dad go fishing, and they catch a fish, and the fish has spines on it, and the kid picks up the fish, but after touching the spines on the fish, which hurt, the child asks his dad to hold the fish they catch. So notice that this behavior of asking his dad to hold the fish was evoked, or another word, similar word, triggered by being, by being poked by the spines on the fish. So that didn't involve words. That change in behavior didn't involve words. So the dog barked at the neighbor, so the neighbor walks a different route to work. You ate a bad slice of pizza at the dining hall, which made you sick. So now you stop eating pizza from the dining hall. Again, it doesn't involve words. With each hit of the ball with the bat, the baseball player's accuracy increased. Right? So it's a change in behavior as a result of experience, but it doesn't involve words. So let's do some ASRs. The first ASR here is at the grocery store. You ask the clerk where the saltine crackers are. They give you directions, you follow the directions, and locate the saltine crackers. This is an example of A, learning with words, or B, learning without words. A couple more seconds. Alright, I'll close the poll. And the answer here is A, learning with words. ASR number 2. In the past, the child cried when Grandma wasn't paying attention to him because Grandma was more likely to attend to crying than other behavior. Okay, so there's this problem behavior. The child cries, but the child's crying because it gets a lot of attention from Grandma. Well, the behavior analyst stepped in and trained Grandma to stop paying attention to crying and start paying attention to good behavior under the assumption that crying is a behavior that can be explained through the child's, by referring to the child's experience, and the child's experience was that the environment, Grandma, was providing a lot of attention for crying and not for other behavior. Okay, so the behavior analyst said, stop paying attention to crying, start paying attention to good behavior. And so Grandma did this. And as a result, the child stopped crying with Grandma and then started interacting with her more positively. Now, in relation to the child's behavior, that is, focus on the child as the learner, this is an example. Oh, I'm sorry. In relation to the child's behavior, this is an example of A, learning with words, or B, learning without words. So this is in relation to the child's behavior. The child is the learner. Give a few more seconds. Alright, I'll go ahead and close the poll. So the answer here is B, this is learning without words, because Grandma didn't say anything particular to influence the child's behavior. All she did was start paying attention to one topography of behavior and not paying attention to the topography of crying. Right? So learning was a result of the child's experience without words, that is, just a change in the allocation of attention across different topographies of his behavior. Now, if you had, it's possible you had focused on Grandma's behavior, and if you did, and if the question were about Grandma's behavior, then we should conclude or classify that Grandma's behavior was a result of learning with words, because the behavior analyst trained Grandma by telling her, don't pay attention to crying, pay attention to this other desirable topography of behavior instead, and then it's going to improve his behavior. Okay, so that's a contrast for you: learning with words, learning without words. Okay, objective 3 is to define data and datum, and then discriminate between examples and non-examples of each. And the reason why we're talking about these terms, data and datum, now are so that you can begin to talk about graph data accurately, and that's important because throughout this course, as you start to learn more about the fundamental principles of behavior, and you start to learn more about how behavior works and how learning works, you'll come to realize that the way we understand how behavior and learning works is through graph data. We make observations of behavior, we repeatedly collect data on the behavior over time, we graph those data, and then we use graph data through experimental design methodology called single subject or single case design. We use that to draw inferences about functional relations between behavior and environment, or we use it to draw inferences about the environmental variables that were responsible for the learning that occurred. Okay, so we're really just getting warmed up here and first talking about the use of the terms data and datum. And I also want to highlight in advance here that in everyday life, talking with peers or colleagues who are also studying or working in behavior analysis are almost never going to use the word datum. Okay, so the purpose of this portion of the lecture is just really to help you use the word data correctly. Okay, so data are the results of measurement, usually in quantified form. A single value is referred to as a datum, and a single value in a graph is represented by a single data point. So a single data point is a datum. And what do we now? And Johnson and Pennypacker are here by saying that the data are the results of measurement. It's that data are the result of the teacher or the clinical practitioner or the researcher's behavior of observing and measuring, assigning values to the behavior they observe or the aspect of the behavior they observe, quantifying it. So when referring to data, we say these data or those data or the data, but we never say these datum, and we usually don't use datum in conversation. We never say that data, and we usually don't say this data. Okay, so think of it this way. If there were cows in a pasture or out in a field, you wouldn't refer to the cows in the field as that cows, right? And you wouldn't point to them and say this cows. You would say these cows, or those cows, or the cows. And if you were referring to a particular cow, you'd say that cow or this cow. So the use of the terms data and datum are the same here. So here are some examples of data. In each of 3 therapy sessions, the child engaged in aggression 3 times, 7 times, and 9 times respectively. So we would say these data, or those are the data, or the data are, or the data were 3 times, 7 times, and 9 times per session. 10 math problems were solved correctly on Tuesday, 5 on Wednesday. So imagine if you had a graph with the day on the x-axis on the bottom. So you're plotting Monday, Tuesday, Wednesday, Thursday, Friday. And then on the y-axis, or the vertical axis on the left side, it said 0%, or so these are the account data. So it would say 1, 2, 3, 4, 5, all the way up to, let's say, 10. Okay. And so you would, when you graph these data, you would go to Tuesday and then go up and put a dot or a data point at 10. And then you would go over to Wednesday and then go up to 5 and put another data point. And so when you describe what you wrote in the graph, you would refer to what you wrote as these data, or those data, or the data. And so the data point for Tuesday, with 10 math problems correct, would be a datum. At the 7 p.m., 8 p.m., and 9 p.m. time points, the infant cried. Those are data. The values from all of the measurements of behavior during a therapy session are the data. The data suggests he answered 18% of questions correctly across each of 5 consecutive sessions, so no learning occurred. That's the way you would use the word data in a sentence to summarize. Okay. The data show that workplace injuries due to incorrect machine use occurred on average 4 times per month for 3 months. So notice we would not say the datum show that, or we wouldn't say that data show that workplace injuries due to incorrect machine use occurred, blah, blah, blah. It wouldn't be the correct usage. The correct usage is the data or these data. That would be the best way to say that. So here are examples of datum. The bird pecked at the key light 70 times during the session. That would be 1 data point on a graph. That would be a datum. On Friday, the behavior happened 2 times. So on a graph, you would go to Friday and then go up to 2 and put a data point. That's a single datum. Okay, so let's look at some graphed data. And what I really would like to focus on is the top panel. This is the top panel, and this is the bottom panel of this entire figure. And so first, this is a study I conducted with Terry Falcomano, University of Texas at Austin, during grad school. And so what I'd like to do is just tell you about this study, and then I'm going to ask you some questions about learning and about data in the next few ASRs. And I want to just focus on the top panel of this figure first. So the first thing you do with graph data is a general overview by describing the features of the graph to the audience. So what we'd say first here is, well, the x-axis represented sessions. There were 30 sessions. On the y-axis of the graph in the top panel of this figure, we display the percentage of trials with independent variant consumption from 0 to 100%. And there were 2 conditions, lag 0 and lag 1. You can see those conditions were repeated across sessions. Right? So this was a study of the effects of a lag schedule of reinforcement on variability in food consumed by a boy with food selectivity and autism spectrum disorder. So I'll give you some background here. So autism spectrum disorder is a neurodevelopmental disorder characterized by social communication delays or deficits and restricted or repetitive or stereotype behavior. And for children with autism, a large majority also exhibit a pediatric feeding disorder. Now, pediatric feeding disorders can range in severity from moderate food selectivity to severe food refusal. So let's focus on the food selectivity side because this participant was food selective. Now, with food selectivity, the child consumes a highly limited variety of nutritive foods and engages in disordered feeding and mealtime challenging behavior. And typically there are no medical factors associated with the disorder, and the limited variety of foods consumed cannot otherwise be explained by deficits or delays in oral motor skills like chewing or swallowing. Now, for example, a food selective kid would maybe eat 5 to 6 foods in total, like that's their entire diet, and typically the foods are non-nutritive, like Cheeto Puffs or cheeseburgers, pizza, chicken nuggets, French fries, stuff like that. And so this particular kiddo had food selectivity and ate a limited variety of foods similarly, and he also engaged in the disordered feeding and challenging behavior, which are characteristic of pediatric feeding disorders. But we're actually gonna skip that because that's not the focus of this study. So the focus of the study was to see how a particular way of delivering reinforcement might influence the variety of foods that this boy ate during sessions. Okay, so basically what happened in each session consisted, this study was conducted in his home, and I ran the study. Each session consisted of, let's say, I think it was 11 trials. And a trial began with presenting a plate of food with 5 bites of food arranged horizontally on the plate. Each food was different, and they were identified by his caregiver to be foods that he readily consumes. And he was told to take a bite. And if he took a bite, regardless of what the food was, I gave him access to toys, high preferred toys, for 30 seconds. Okay, and then after 30 seconds, I would take the toys off from the plate with the full 5 pieces of food, but rearranged on the plate this time, and I'd say take a bite. If he took a bite, then I'd give him the toys for 30 seconds. If he didn't take a bite, I would withhold the toys. Okay? And so we would run 11 trials, then take a break, and then do it again. And then do a couple sessions, and come back the next day and run a couple more sessions, and so forth. And so what we graphed are these data here, which was the percentage of those trials that he ate a food that was different. So let's say on the first trial, he ate a piece of popcorn. And then on the next trial, he ate a peanut. Well, because the peanut was different than the last food he ate in the session, which was popcorn, and that was considered variant. That means, it was different. And so that's an instance of variable consumption. So for example, let's say in the third trial, he ate another peanut. Well, the peanut's the same as the last trial, he ate a peanut. So that wouldn't be variant. But on the next trial, let's say he ate a veggie stick. Well, the veggie stick's different than the peanut, the last thing he ate. So that's variant. So that is a variant response. Okay, so anyways, in the first session, 90% of trials, he consumed variant food, right? Okay, so, but as we continue to conduct sessions, you can see that the food choices he made became more repetitive. For example, in the last of the 4 sessions, only 20% of trials did he eat a food that was different from the last food. Then we introduce a treatment condition. This is called a LAG1. And in a LAG1, lag schedules reinforce variability. So the purpose of the study was to see if I can get the variability in consumption to go back up. And what I did was that now during the sessions, if I presented the plate and said take a bite, if he ate a bite of food that was different from the last food he ate within the session, he was given the toys for 30 seconds. But if he didn't, but on a trial, if he ate a food that was the same as the last food he ate, then I would withhold the toys for 30 seconds. Then I would present another trial. If it's different, if he ate the same food again, withhold the toys. Then present the next trial. This time he eats a different food, give the toys for 30 seconds. Right? So access to high preferred toys was delivered contingent on each instance of variant consumption. Now I want to point out that I didn't say anything to him. I didn't tell him to eat anything different. I didn't say, well, eat something different this time and then I'll give you the toys. Nothing like that. I've just described to you exactly what the procedures were. It was just take a bite. If he, depending on what he ate, I either gave the toys or didn't. So what you can see in this graph here are the data that were collected in lag 1 session. You can see that initially the first few sessions it showed an increase in variability and consumption, and it started to slowly taper off here, gradually decrease across these sessions. And so it wasn't clear exactly what's happening, so what I did is I returned to lag 0. The lag 0 is the condition where it didn't matter whether the food was different or not, or variant or not. I gave him the toys for every food he consumed. And you can see that there was this dramatic and sustained decrease in variability in food consumed relative to this condition. Then I reintroduced the lag 1 schedule in this final treatment condition, and you can see there was a large immediate increase in variability of food consumed, just like we saw in the beginning of this initial lag 1 phase, which suggested that he learned that in this condition, the only way to access toys is to eat a food that was different. And so this is an important finding because it suggests that when children with autism consume a very limited variety of foods available at the same time in a given meal, then you can arrange consequences without saying anything and predicting and control the variability in the food they consume. In other words, help them to consume a variety of more nutritive foods in a given meal. Okay, so those were the data I collected in that study, and that's how we interpreted the results based on those data. And so everything in the circle here we would refer to as data. We would refer to the single data point as datum. Okay, ASR 3. The participant in Silbaugh and Falcomata 2016 learned A with words or B without words. Maybe a few more seconds. Alright, I'll close the poll. The answer here is B, without words. We controlled variability in consumption by arranging contingencies or delivering consequences if and only if we observed the aspect of behavior we were looking to increase. But we didn't use any words to achieve the change in behavior. ASR 4. In this figure here, with a top panel and a bottom panel, A is pointing to this circle around something right here. And so the question is A pointing to A datum or B, A data or B datum? A couple more seconds. Alright, I'll close the poll. And the answer here is B datum. Alright, so that wraps up this video part. I'll see you in video part 2, beginning with objective 4.